Hey, good evening, everyone. Um, my name is Rajneesh, and today I would like to talk a little bit about Cisco's journey with AI. And as a part of that, I would also talk a little bit about AI in IT operations, which is AI ops. And I would want to walk through a couple of use cases and do a case study. And while doing that, probably we'll also find out what are the type of customer challenges that we have. Are you able to hear me? And the customer challenges that we have and what kind of use cases that exist as of today. So having said that, uh, most of us probably associate Cisco as a networking giant. We know Cisco for its routers, for its servers, and its switches and so on. But for the past few years, Cisco has been significantly making a lot of investments and innovations in AI as well. And as you can see, if I had to stack down an AI model, there are infrastructure, data, model, tool chains, as well as applications. And Cisco has a presence in each and every, I would say, layer of the stack. And not just that, it also has services as well as observability and security, which spans across the stack. So, from a customer standpoint, if I had to take a customer AI journey and I had to lay it down in phases, it would start with a plan and selection of use cases. Then it goes on to a deploy and design use case, and then develop a data strategy and have infrastructure laid out, and then have some kind of deployments of the application and so on. And Cisco has a presence for each of these AI journey layers, uh, as well as some amount of end-to-end security and observability for all of these aspects as such. Now, if I have to look at some of the customer challenges. Now, customers can be of different types. It could be a service provider as a customer, it could be an enterprise, it could be retail, and so on. So, what I've tried to do is I try to bucketize larger customer challenges, which could be agnostic of the type of the customers. Largely, one of the bigger challenges is infrastructure scalability. What has happened in the recent past is the traffic in general has grown by multiple folds, because of which if you have a legacy system with the customers, typically there would be 200 plus percentage of growth in the traffic, and that means it becomes a nightmare for the legacy system to handle it, and there is an urgent need for modernization. That's one of the bigger challenge. And then there is an resource optimization challenge. Most of the companies still have 65 to 70% of their IT budgets invested on manual processes, which means there's very little room for strategic initiatives. That's another challenge that I can see. In some of the third challenge, which I can think of, is customer experiences and demand. Uh, Most of the industries, specifically if I had to talk about service providers, they have this 99.999 percentage of uptime which has to be guaranteed, which means there is an 24/7 service support which is required. And most of this service support, you can say approximately 70% of it is a monotonous service support, which could be easily automated. That's another challenge which you can think of. And market competition, there's always somebody new coming at much cheaper cost, utilizing AIs and other things, which makes it 30% plus lower cost rate. So these are some of the larger challenges which I put. Uh, One of the case studies or a use case which I want to discuss today is life cycle of an incident. When I say in incidents, it could be because of any changes that goes into any of the network or any such things, which could result in incidents in general. So typically, most of the incidents today, as of today, is handled manually. And when I say manually, once a change is made, there's an incident and there is a technical expert or an engineer who's sitting and detecting and prioritizing, wherein he identifies if there is a real issue, or if there is an issue, how important is that issue, and he has to figure out if this issue impacts X amount of domains and so on. And then he has to isolate the issue, wherein he has to identify whether where this issue is coming from, and who should I contact if I'm not able to resolve this issue and so on. And then diagnose the issue and probably go ahead, and once he's diagnosed the issue, he finds out what should be the remediation, and then push the remediation. It could be a change in config and so on. So all this requires multiple number of engineers who are well versed with the domain, who has a good understanding of the domain, and it can take anywhere from a few hours to a few days, depending upon the type of incidents that is. So we can, towards the end, we can see how AI could help in reducing the whole time for issue resolution, right from mean time to detect all the way to mean time to remediate as such. So here, I would like to talk a little bit about AI Ops, which is AI, artificial intelligence for IT operations. This picture is sourced from Gartner, but principally it has three main phases. One is the observe phase, there's an engage phase, and an act phase. So while we discuss use cases and we talk about AI, it's very important that we get the right type of data, and the right type of data could be anything. It could be voice data, it could be even traps, it could be SNMPs, it could be metrics, any kind of data. It's important to have the right type of data. It is important to have the data almost real time if possible, and it's also important to have the right quality of data so that the data can be acted upon. So the observe phase is all about collecting the data, maintaining the history of the data, and be able to come up with some kind of an historical analysis wherein you can detect an anomaly based upon laying it out as such. And then comes the engage phase, where you now have the data, you have an idea of the history of the data, you have an anomaly which is detected. Now you go back to your knowledge base, which could be in terms of the number of cases that has been raised and so on, and identify what could be a remediation for it, and then identify what should be the solution and detect the solution as such. And then comes the act phase, wherein the solution comes with probably changes that needs to be pushed back to the network or so. It could be some kind of configuration changes, it could be some kind of an flipping of a node, or it could be even a hardware change or something like that. So act mainly is having scripts or playbooks which can push those config changes or push those changes back to the network, and then it again revolves back with the observe, engage, and act phase till about a steady state is reached. So this would be a cycle, I would say, that's very commonly used in the AI ops as such. Like I mentioned, AI ops, it has the observe phase where you have the data, and the data along with the algorithms and the history gives you an operational insight, which helps along with the knowledge gives you what's called as the decision that could be taken, which could be a change and so on, and the decision along with the tools or the can result in action as such. So with this as the background, now if you go back to the incidents or the life cycle of the incidents which we're talking about, where we were trying to handle things pretty much manually, I just taken one aspect of that, which is wherein the issue has been detected, has been isolated, there's been a response which has already been figured out. Now it's a matter of pushing those changes back to the network so that we can have those we can have the remediation as such. So in an on top, what you can see is everything is done by humans, wherein only the pushing of the configuration or the change or the remediation or the act phase of the AI ops, if done manually, would take at least 2 to 3 hours, and 1 or 2 engineers who are well versed with the knowledge, with the network and so on, wherein they detect the signature, they probably identify the method of procedure, and then they connect to the remote servers and execute the mobs and then observe and so on. When done with AI ops or with agents or AI, which is shown below, it could take just one engineer and just minutes of time. So imagine if we could do the whole cycle, what used to take probably a week or 2, or depending upon the complexity of the incidents, could be done in minutes as such. So here I have tried to list down a few use cases which are more relevant, or are the ones which we are also discussing with many of our customers as such. So I can read out the use cases, but broadly, if I had to categorize them, it depends on the customer journey where they are. There are many customers who are very early in their journey for AI adoption. So those are the customers where detection is an important aspect of it. So for example, security threat detection, fraud detection, these are some of the cases which are more relevant for the early in the engagement AI customers. And then there are customers who are probably a little more matured in their journey, where detection they're past the stage of detection as such. So there you can look at optimization as the use cases, where now they have infrastructure where they are able to get all the data locally and in a single pane of glass. They're able to visualize it, they're able to trend it, they're able to predict they're able to detect the anomaly. Now it's a matter of how can they optimize the network, how can they make sure they're using maximum of their resources and so on. So traffic optimization management, uh, energy efficiency, churn prediction, customer retention. These are some of the use cases which can be categorized as the intermediate stage of customers. And then there is the third phase wherein customers are moving towards uh, proactive management as such. So if I look at predictive maintenance, where even before an incident happens, even before there is an issue seen, if there is a possibility for the customer to predict it and be able to nip it at the bud, those are some of the use cases which could probably be relevant for the advanced stage of customers. Having said that, I would like to conclude with just reiterating on the value or the AI value. Uh, like you can see, there are multiple buckets in which AI can add value. There is predictive maintenance that could reduce the network downtime by approximately 45% of the time. There's smart capacity planning that could help almost prevent 90% of the potential service disruptions. Resource allocations, it can cut operational costs by approximately 25%. These are some values which we have seen from our past experience as such. Automated customer support, like I said, pretty much 70% of the queries can be handled without human interventions. Network optimization is another aspect where improvisation of the bandwidth utilization can be up to 35%. And then there are security threat detection AIs, which can help detect the security threat 5x times faster than the traditional methods as such. With that, I'd like to conclude what I had to say. Thank you.